Welcome. My name is Marit van Dijk, and I'm here today to talk to you about keeping your dependencies in check. And I know that Theresa and Kari did a talk about something similar earlier today, but I hope I can tell you some different things as well. Open source is everywhere. This is where I usually check who uses open source in their work or side projects. And pretty much everyone raises their hand. So yeah, same results every time. So open source is nice because we get a bunch of functionality without having to write it ourselves, right? I would much rather use a testing framework than write it myself. But there are downsides as well. For the dependencies that you declare, you get transitive dependencies. And for those transitive dependencies, you might have potential collisions. All of those dependencies add up, leading to bigger binaries and longer startup times. And they may contain vulnerabilities. So who remembers what happened last December? Yeah. That was fun, right? Fun. Log4Shell was disclosed in the Log4j logging library that a lot of us use. And the severity was such that we all had to update all of our applications as soon as possible. In some cases, twice. I had to do it twice because we got it done fast the first time. The downside was that we had to do it again because after the first vulnerability, several others were disclosed. Fun times. And then in March of this year, we got to do it again because of Spring4Shell. The upside, of course, being that we had just practiced this in December, so at least in my case, it was faster this time. But overall, there are pros and cons to using dependencies and different ways of dealing with that. One way, of course, is if we just don't add dependencies, then we have less to stay on top of and update, etc. But the downside is you'd have to write everything yourself. And I have seen projects where they prefer to write their own mocks instead of using mocking libraries, or just write as much as they can themselves. But the downside is that's more work. You have to do everything yourself. Alternatively, you can just use all the dependencies because they're cool and useful, but that means more dependencies to stay on top of. So overall, it's a balance. There's a reason that the answer to all of the questions in software development is it depends. So when selecting dependencies, think about whether you really need them. And let's take a look at some of the things that we want to consider. The first thing would be, does it fit? Does it fit our problem? Does this dependency solve the problem that we want to solve or do the thing we want to do? And does it do so in a way that matches? So if we have a very small problem and a huge dependency, maybe that's not the best solution. Maybe we should just write this little small thing ourselves. Maybe there are other dependencies that do the same thing and we want to compare them and see which one we prefer. Maybe we already have a library that does this and we don't need another one. Another thing to consider is how well maintained a dependency is. So check out the number of commits and the number of releases and see how many active maintainers and contributors there are. There's an XKCD for everything, and I know this one came up earlier today as well. There are a lot of dependencies or libraries that are maintained by just one person. And one thing that comes up then is what's often called the bus factor. So if this person gets, or how many people get hit by a bus before this dependency becomes unmaintained. I don't really like the bus factor because I don't want to think about people getting hit by a bus. So I prefer the lottery factor, how many people can win the lottery and never have to write code again before this dependency becomes unmaintained. I mean, unless they want to write code for free. So in general, there's a problem with open source software that there's not enough people to help maintain it, but that's another problem. Another thing to consider when selecting dependencies is the community. If it's a popular product or library, there will be more people who are talking about it, writing about it, who might be active in communities to help other users and answer questions. And another thing is the community helpful and welcoming? So are they okay explaining the same thing to newbies? Or do they get annoyed when the same question comes up? Of course, it's important to know if it's easy to use, easy to implement. Is it well documented so you can find answers to your questions? And do you like using it? Because often there are multiple options, and use the one that works for you and your team. Also consider what is the impact of implementing this dependency. Some will be small and contained, and some will take over your code base, like Lombok or a reactor. And then if you ever want to move off of them, it will be a lot of work. And finally, if you decide that you do want to use a dependency, make sure that you use the latest stable version and that there aren't any open known vulnerabilities in that version. So where can we find this information? We can go to Maven Search, where I'm using Jackson Databind as an example. If we search for Jackson Databind, in the latest version, there won't be any vulnerabilities. Maven Search links to the OSS index by Sonatype, so you can see whether there are any vulnerabilities, known vulnerabilities in these dependencies. If you go to an older version of Jackson Databind, there will be vulnerabilities found. Another place to look for information is Maven repository. Here we can see the different versions, whether there are any vulnerabilities known in those versions, usages, so other artifacts that use this dependency, and when they were released. So as you can see, there are known vulnerabilities. If you then go to that version, Maven repository will highlight that there is a newer version, and it has a link to direct vulnerabilities with a link to that exact vulnerability for more information about that vulnerability. We can look at the code where it's hosted. Often that will be GitHub. On GitHub, we can see when was the latest commit, the number of commits, latest releases, number of releases. And we can also go to issues and pull requests to see how many open issues there are. For example, whether there are any open issues with regards to whatever functionality you want to use, but also see how the community or the maintainers interact with people who report issues or submit pull requests to see whether they are, again, open, welcoming, and friendly. We can also go to the insights to see a graph of the activity over time and the number of committers, etc. At JetBrains, we also have the package search website where you can search for dependencies to get some information, and it combines information like you can find at Maven repository and GitHub. For example, you can find the latest release, license, who are the developers, tags on Stack Overflow to see whether there are lots of questions and whether they are being answered there, a link to the website and the source code. And in the version tabs, also a list of the versions that are out there. And package search is integrated in IntelliJ IDE. Now, I know the question was asked in the previous talks, but who uses IntelliJ IDE? Still pretty much everyone. Thank you. I'll show you a little bit about that in a little bit. So most likely you'll have dependencies in your projects and you'll have to maintain them, which is not our favorite thing, right? It's boring and repetitive and we'd much rather be coding something. So let's take a look at some of the things that we can do to make it easier. If you're using Maven, you can use some Maven commands to get information about your dependency tree. So the dependency tree will show you your declared dependencies that you have in your pom.xml, as well as the transitive dependencies they bring in. But we can also check for updates using display dependency updates, which will tell us of our declared dependencies, which we can, where there are newer versions available. Of course, we'd have to manually check those out and update them. We can also use dependency analyze to see if there are any unused declared dependencies. By the way, I'm using a really old project from my GitHub for these examples. I wrote it in, or I built it in 2017 and haven't updated it since, so it's a very bad example of code, but it's a perfect example of an unmaintained project. You know, because it's always nice to grab something from your graveyard of GitHub projects. A term by Tom, who's right here. You can do similar things in Gradle, so you can ask for the dependency tree in Gradle. If you want to see the dependency updates, you need a plugin, for example, by Ben Mains. And like I said, in IntelliJ IDEA, we integrated package search. So if you have older versions in your pom.xml, it will do the little squiggly line to suggest a new version, as you can see here. That also works in Gradle. This is the Spring Pet Clinic project. And if you have Ultimate Edition, it will highlight in yellow if you have a version that has vulnerabilities, and it will link to more information about those vulnerabilities. And that's a collaboration with Checkmarks, a security company, and they provide the information about the vulnerabilities, sorry. I'll share my slides at the end, so if you want to take pictures now, great. If you want to look back, take a picture at the end of the link. Also in IntelliJ IDEA, you have the dependencies tab, and here you can see the dependencies that are in the project. Again, this is the really, really old project with everything is outdated, so you can upgrade them here. You can also add dependencies here or remove them here. And you can see at the right some information about the project. So of the things I showed you just now, they can be useful if you have nothing else, but the downsides are you need to check out each individual project and see whether there are dependencies that you can update in that project, and then apply and verify those updates. A better solution would be to use software composition analysis. There are a bunch of tools available for that. I worked at bol.com until recently, and there we had such a tool that scanned all of our repositories and our Docker images for vulnerabilities, and we had, as you do, an internal tool that showed us a list of what was outdated for our team so that we knew what to update. And hopefully your company will have something similar. And the upside here is that you don't need to check out each individual repository to know where you're vulnerable. But the downside is, as a developer, I do still have to go to this dashboard to check what I need to update. So the next option we have is to use bots. For the JVM, we have 3 options: Dependabot, Renovate, and Sneak Open Source. If you're using different languages, there are a bunch of other bots, but I use mainly JVM, so I'm looking only at these. Dependabot is GitHub native. It was acquired by GitHub in 2019. And it includes several options: Dependabot alerts, Dependabot security updates, and version updates. Because it's GitHub native, it's extremely easy to implement on a GitHub project or profile, you can go to your profile and then settings, code security and analysis, and you can enable which features you want. If you have it enabled, it will show this highlight on your project if there are outdated dependencies or vulnerable dependencies. This is my old project that I'm using as an example. And then if you click the button See Dependable Alerts, it will go to a list of the outdated versions. If you set the security updates, it will create PRs for you. This is what they look like, and you can interact with those PRs using commands. So you can see at the bottom, dependable rebase, for example. So you can close, ignore, merge, or rebase, or reopen them, depending on what you want. To enable dependable version updates, you need to add a configuration file and tell it what package manager you're using and where to find the manifest file. You can set the frequency to daily, weekly, or monthly, and the schedule as when it should run. You can configure the number of PRs, which will have a default of 5, and you can add some details to manage the PRs, like who to assign it to, who should review it, what the commit message should look like, whether it should add any labels, and a rebase strategy to say whether you want it to automatically rebase or not. The next option is Renovate by Mend. This is available also on GitHub via the GitHub app. I'm only comparing these, how to use them on GitHub. Of course, there are other options like GitLab, etc. I didn't have the time to go through all of the combinations, so I'm just going to compare the features of the bots on GitHub, and of course you can use them on different systems as well. At Bol, we use Renovate on GitLab, for example. So to enable Renovate, go to the Renovate app on GitHub, click Configure, and it will give you the option to apply Renovate either to all of your repositories or to only selected repositories. And this is the only one of the 3 that allows you to do that, to select only one repository. So if you just want to give one of them a try, I'd recommend this one. You can try it on just one of your repositories. If you enable it, it will create a pull request to add the configuration to your project. So it will add a small config file, and once you merge that, it will start running. As far as configuration, you can select all of your repos or only selected repos. The configuration file is created for you, but you can add to that. You can, again, limit the number of PRs, but you can also limit the number of concurrent branches. You can even set an hourly limit to avoid getting spammed by lots of PRs. And there are more options, and the options are more fine-grained than for Dependable. The PRs give you a little bit more information. So it will give you the age, which is the age of the package that it's suggesting you use. Adoption rate, which is the percentage of this package users within Renovate that are using this release. The passing is a percentage of updates which have passing tests for this package. And the confidence level as determined by Renovate on how confident they are that you can apply this version, where neutral means either they don't have enough information or are unable to make what you might call it, to determine the confidence level. They also add a dashboard that will give you an overview of all of the updates that you need. Snyk is a security company. Brian Vermeer is at Devox. He did a great talk, I'm sure, on deserialization issues. He works for Snyk. So they have several products. The one I'm looking at today is Snyk Open Source, which you can try for free. To enable that, go to their website and authorize a Snyk login. You can select to apply it only to public repos or public and private repos. And they offer several other options that the previous bots don't. One is to test for new vulnerabilities when you create new PRs, which is super useful because you can make sure that you don't add vulnerable dependencies in between the scans. You can create pull requests to fix vulnerabilities or just upgrade out-of-date dependencies like Dependabot. And you can test for vulnerabilities in your source code. You need to create a personal access token to enable it, and then it can create PRs for you that will also provide some information about the vulnerabilities that are being mitigated in a new version. And another thing that they do is they can bundle PRs for updates that are related, which is something that, as far as I know, the other two bots don't do. And this is useful to prevent getting spammed by too many PRs, because if you get too many, then it creates a bunch of noise. And like I said, they can do checks on new PRs to make sure you're not adding vulnerable dependencies. They also offer a dashboard when you enable Snyk open source that will show you vulnerabilities and their severity in your projects. They have limited configuration. You can set the frequency to daily, weekly, or never, although I'm not sure when you would do that or why. You can enable or disable to check for new vulnerabilities only, so anything that is found as of now, or for known vulnerabilities if you want to make sure to get rid of your backlog of known vulnerabilities. And you can enable or disable PRs for individual projects. So the pros and cons of bots are that they're relatively easy to install and they create automatic PRs for you. You can then see in your build whether a new version passes your build. And if it doesn't, then you know, oh, we have more work here. But even if it does, you still need to make sure that you can deploy that because how confident you are will also depend on your test suite. You'll still have to manage the PRs that are created, so you need to decide when to merge and when to deploy them. Even if they're small, you still want to maybe check that once you deploy it, your error log doesn't blow up or everything still works as intended. And if there are any code changes that are needed with a new version, these bots cannot do that for you. But there are several tools that can. One is error prone. Sander Mak is doing a talk on error prone right now in a different room, but I'll link to a previous video of his. Error prone is a static analysis tool for Java that catches common programming mistakes at compile time. So it's intended to help you find and fix security bugs. It works with Maven, Gradle, and a few others. It has a bunch of bug patterns that it already has identified, and you can set it to either report on those or to automatically fix those for you. And you can create custom checks. And it's integrated with Refaster, which is a way to refactor code using before and after templates. So we want to go from this to that. Like I said, Sander is doing a talk on that right now, which he's also done at JFall and JSpring in the Netherlands. And he also explains how they used error prone to migrate from Java 8 to Java 11. So even though it's not intended as a migration tool, you can use it as such. And it brings other useful functionality. Another migration tool is Open Rewrite. I don't know if anybody was here on Monday, because Tim de Beek did a talk on Monday on Open Rewrite. I'll have a link to that in the next slide. So Open Rewrite is a source code refactoring for framework migrations, vulnerability patches, and API migrations, and it focuses on Java for now. They are planning to also include Kotlin in the future. It works with Maven and Gradle, and it has a bunch of existing recipes, as they are called, or basically migrations. For example, from Java 8 to 11, from JUnit 4 to 5, but there are a bunch of others. And you can also author your own recipes. Yeah, Tim de Beek has a lot of experience with that and did an excellent talk on that last Monday. So if you want to know more about Open Rewrite, have a look at that. So in conclusion, re-evaluate or evaluate your dependencies carefully before you start using them, but also periodically re-evaluate whether you still want to use them, whether they are still maintained, whether you might want to replace them. Automate checks and updates as much as you can, and stay safe. And if you want to see the slides, you can find them here. Thank you.